Hello everyone, welcome at our core protocol sync. This week we'll share updates on the protocol networking, farmer and related stuff from last week and plans for the future. And the first one today will be Shamil.
Okay, sure. Let me share my screen. Last week I worked with last changes for networking parameter manager. I fixed last review comments and got it merged. After that, I worked with bug that we have is bug that we can encounter on large plots mainly. One of the parts of the P2P library, Yamux multiplexer, glitches sometimes on some when we get, for example, 47. And initially, I tried to change that multiplexer to implementation called Mplex, but it seems it doesn't work well. Ivan encountered some issues. He contacted me, and I rolled back to the previous version. Meanwhile, I tried to work with some parameters of that Mplex. I changed request size, buffer size, but I didn't like the results. It seemed inconsistent. It works in some runs and it doesn't work in next run, so I didn't like it, and I rolled it back. However, it's very strange that today I tried to reproduce the bug on our latest main, and I wasn't able to do that. I'm not sure why. We have several PR merged. After that, I rolled back, so we need to just debug it more. Why this bug disappeared on Yamux multiplexing enabled? Probably it is because we have this Yamux multiplexer not directly now, but as an upgrade, having both Yamux and Mplex together, but choosing Yamux as the first one. But it's a long shot. We need to test it. Also, I
have a question on that.
Yeah, sure, please.
Is that because we have the multiple networking identities for one farmer based on each plot that it has?
Most likely, it's not 100% because multiple networking instances good suspect for that, but we also have relayed configuration. We have this special nodes and that relay our requests to our plot instances. So it's probably because of multiple networking instances, but not 100% guarantee. It's also could be because of that relaying configuration. In your theory, there is one argument that we basically don't encounter those errors in simpler tests and minor plots, like for example, 1 GB and 10 GB in local scenarios. But for 47 terabytes, it's almost consistent behavior on my local machine.
And at 47 terabytes, we'd have 470 networking instances.
500 instances, yes.
Probably we just trigger some edge case in that scenario.
But
okay.
We cannot guarantee that it's about networking instances number. It could also be in our relay configuration. So it's not clear.
Mm-hmm. Well, with the next consensus of your audio is coming in really broken, Shamil. It's like every now and then your audio just disappears.
I try to reconnect.
Okay.
You are muted.
You're muted.
Is it better now?
So far.
Okay.
Yeah. I guess what I was gonna offer is that with the new consensus upgrades based on the new spec we've been putting together, there's just going to be like a what's it called, like a multi-plot farm, like one multi-plot farm or one farm, basically one networking identity regardless of the size of the amount of space pledged. And so I'm just wondering, we've been working on this for 17 days, if maybe it would be, if we could just accept that it's not going to work right now, but for the next iteration, it might be better.
Yes, I'm looking forward for that, for the next version of consensus to reduce this networking instances number.
Okay.
Yeah, my concern is that it's just some kind of edge case that you are triggering, maybe like spike in network usage or something that might happen in other cases. So it would be nice to like report it upstream and let them figure out that what is going on wrong in that case. But at least we have like a tool to reproduce it, at least in some shape or form.
That's also true, and the application works after those glitches, so it doesn't seem to break completely.
So is there anything else that we can do on this one, or is it possible for us to just put this on hold until we can verify that it doesn't happen with the new version of consensus?
I think that the best way we should contact the protocol labs with a report that we are going to send today. We could also try to debug that protocol ourselves, but it will take some time, and it's unclear that we will make it. Also, it doesn't seem to have those problems right now. I need to debug more because it just disappeared. The bug disappeared in the current main.
Well, I think it's just an edge case. Maybe upgrade does fix that edge case. That's funny.
Okay. So do you think, Nizar, we can just submit this report and leave it for now?
Yeah, if you don't have any like clues onto the problem, then just report it and see what happens.
Was there, I'd heard there was like a major vulnerability in the P2P that was revealed last week. Are you guys aware of that?
There was something, we knew that something was happening like weeks ago. There was a recommendation to upgrade Substrate, and we upgraded a few times, but I don't know the details yet.
Okay. I was actually just talking to somebody last week, and they just mentioned there was this major vulnerability that was discovered, but apparently it was just last week or something. But okay, so I wasn't sure if we were.
I think it might be just announced last week, but some people knew about it for longer.
Got it. Okay.
Okay, I will continue then. There was a small bug just for the development. I added some signal feature to Tokyo Crate in the cargo toml in the small PR. Also, I removed the relay node from Kademlia. I filled it out. Basically, relay node doesn't contribute any features to that our network, and they cannot respond to the requests in proper fashion. But our recent tests, mainly from Ivan, showed that it's not actually the case, and we probably need to think about more. It turned out that removed relay nodes prevents other networking instances from plots to be connected to the DSN. In the tests, it wasn't obvious because I just put those nodes as bootstrapped, and they were connected explicitly. But our tests showed that it's not the case in general, so we need to think more about that, about our role of relay nodes in the Kademlia DSN. Also, I started to create a peer info protocol that will help for our synchronization. Basically, this protocol will respond for each node for its state of the syncing process. For example, whether it supports the syncing process, just for nodes, it will be unsupported, not supported. If the farmer is syncing itself, that's the state will be syncing, and for all other cases, it will be ready for sync. This information will help farmers to decide whether the spear is appropriate for syncing. We plan to extend this protocol more. For example, then additional information could be put in this state, would be current pieces for that for the plot that it gets for that. So it could be useful for syncing to get this decision of whether we should take this information from this peer. So that's it. So my plan for this week is to probably debug more large plots, because it was a surprise for me that the bug disappeared after several PRs. It's just very weird. And after that, I will probably start to work with Bootstrap node application.
I didn't update Yamok's Muxer explicitly or intentionally, but it might have been updated with the substrate upgrade as well. Just like as some nested dependency.
Okay. I could just locally roll back all the changes.
I can just look at the log file changes. If there is anything named Yamox that was updated, then maybe. Otherwise, don't bother.
Okay, it's a good guess why it's happened. Thank you.
Okay, any other questions about Shamil's work? All right. Ved, do you have anything to share?
Just have a small one that I worked on this week. Last week. Give me a second. So this one handles a very specific edge case. This one handles a very specific edge case when the salt that is about to be updated happens in the same header that the Eon also changes. In that sense, my initial assumption was that there is always this steps behind, like Eon updates, salt reveals, and then salt gets used in the next Eon. But that seems to be not the case, because it's currently works out of slot numbers rather than block numbers itself. So that was fixed pretty much early, and that's a small one that I've been working on. But yeah. The tests are not so great right now. I think Nazar also mentioned that. I want to update them a bit so that everyone understands how tests are being orchestrated, so that we can find those edge cases. But I'll be working on that soon.
Okay, that makes sense to me. All right, Ivan, what about you?
Yeah, let me just share screen. So basically, during the last week, I was working on the optimization of the piece by range handle with this PR, and accidentally by that I also discovered like some issues, some bugs related to the to that handle. So basically, right now it works as follows. Basically, beforehand we basically before in order to get pieces and indices, we basically queried the plot worker for indices, and after that we queried the pieces individually, separately. Right now I just squashed the event request into one, and that is the main optimization basically. And basically apart from that, that allowed us to optimize it a bit more, in the sense that we basically could sort, for example, the piece offsets and do the sequential seek on the plot file. That was the main optimization. But apart from that, the bug which I discovered was related to the like rolling over the basically piece index hash field. So basically, if we hit like some piece at the top, we would we would overflow into the zero. Basically, yeah. I just added a check for that. And yeah, as I remember, yeah, but that's probably it. Yeah.
I actually was thinking about that, and the fact that you are querying pieces in like portions, so you don't have like a very big request that prevents you from solving. You are actually querying offsets in small batches. If you were querying them in larger batches, then you can probably sort them better and have more sequential reads. Depending on how much time it takes to query the database, I imagine it's faster than seeking on the plot itself.
Yeah, but basically, yeah, as I reported here, like for me, it takes around like 30, 50 milliseconds to query the database for the piece offsets and indices. Yeah, like all of that stuff.
Yeah, so you probably want to query and like read all of the offsets, sort them, and then read pieces in batches after that, instead of like combining that.
I believe that's how we do it. No, like we
it was that way before. You had a separate request for indices and that separate request for pieces, and now you combine them together.
Oh, okay. I mean, like internally, it works like that. We just at first we yeah. Let me just find how it works here. Yeah. At first we just query the piece index hashes and offsets, and after that we just query the piece indices.
Right, but you are only reading so many hashes and offsets. If you had more of them, you can like imagine you have offsets scattered across the whole plot. So if you query all of them and sort, then you can read more sequentially than if you like take first random 10 and you sort them, and then second random 10. There will be more random reads.
I mean, it's kind of a wicked problem because, like, in a sense that we might be interrupted like by some requests to the plot worker, and basically we would need to like do the random seek to the disk somewhere, and after that, like we would need to go back to the to that offset we were querying before.
I mean, in RocksDB, I believe there are different APIs, and sometimes you don't even have the guarantee like what order will be like items will be in, and in that case, it's really better to have the whole range available to you to sort, because in that case, there is another thing we are doing is we are giving suggestions to the operating system about the patterns of reads and writes we will be doing, primarily reads. And in particular, we are disabling read ahead. So by default, on Linux, for instance, when you're reading something, the operating system will try to read a little bit ahead of that, predicting that you will maybe need that data. And we are disabling that. So if you are actually doing this like whole range read for the offsets, we sort them, and then we issue a bunch of requests to read actual pieces. And it happens to be the case that nothing else is actually reading that plot in the meantime. We can actually disable or enable read ahead. And we can potentially just read it more or less sequentially if you are lucky. So I think there is still optimization to be done there.
Okay. I might take that this week if you insist.
I just think that there must be some optimizations that we can do to exceed 0.5 megabytes per second, because that's really, really slow.
Yeah, I
What
agree
are your
on that.
expectations, Nazar, about the speed? What do you think is good speed for this process?
So if you have a hard drive where you can write sequentially 100 megabytes per second, then and you have a gigabit internet connection that allows you to pull 100 megabytes per second, then the write speed should be 100 megabytes per second or close to that. That would be good. So we can just sequentially fill the disk as quickly as possible. Right now we are like 200 times off. So there must be something that we can do, and 100 megabytes per second is not unreasonable on the hard drive, like if it's a 3.5-inch standard disk.
Yeah, maybe it will be closer to that on the SSD. I'm hoping on that.
Yeah, why I was telling you to test the source on the SSD is because the way we are writing pieces is random. However, if you are syncing using DSN, you will write them more sequentially. So if everyone is using DSN sync, then you should be able to read faster until you like replace half of the plot and like there are holes that are randomly filled. So in that sense, I'm just curious if we move the source on the SSD, at least initially, how fast the writes are working. If you have source on NVMe SSD and we can approach the hard drive speed, then we need to work on like reading or maybe like maintaining sequentiality in some way to optimize that. But we at least need to know where the bottleneck is.
I mean, if we sync is fast enough, we could just resync after that, like in some time, probably like in a week or two.
We don't really want to rewrite things or like re-request things unless necessary. Okay. Anything else on your side?
Nope. We'll test like distance sync on the from the SSD. Yeah, and after that, we'll either work on those optimizations which you mentioned. Yeah, or I'll work on the continuation of the DSN sync. Yeah, this will think about design of that. Yeah.
Okay. All right. Let me share my screen then. Okay. You should be able to see this. So one big thing last week was graceful farmer shutdown. It's a pretty big pull request. The goal is to handle standard signals and like Control-C in Windows and shut down the application properly, not abruptly. And there are many commits. I can just open a random one to show an example. So here, for instance, we have a legacy multiplot farm and we have a newer one. And we need to make sure that everything shuts down on drop. And in this case, we have this blocking background task, which is basically a thread that has something happening in it. And the outer shell is just a synchronous function. So you can drop this asynchronous function, it will be canceled, but the background task is still running in the background. So in this particular case, what we are doing is we have this wrapper data structure, which basically calls whatever function you give it when it's dropped. And we are creating this channel that can hold one message. And we are sending the sender into that background task. And we are creating this colon drop guard that holds receiver. So even if you're dropping this asynchronous function, the drop implementation for this whole function will be called, and that will enforce this read to be completed before we exit. So it doesn't matter really how you drop it, how you stop it, you will have to wait for this background task to finish before you can move on. And that is why there are like many components that had this particular edge case not handled, both synchronous and asynchronous code. And in the very end, we were able to just like drop everything and be and have guarantees that everything, like literally everything, like networking, all of the background plotting, encoding, everything is stopped when we return from that drop. And then we can just have the handling for the signals, and that's our graceful shutdown. And it will also be useful for the library, like if you want to do restart on the desktop application side. For instance, if we change the plot size or we want to change the reward address, we don't have to restart the whole application, we can just restart the farmer. However, before, it wasn't guaranteed that the database is not closed or the network actually released the socket, and there could have been other edge cases and problems. So now they should be all resolved using this pull request. Any questions or concerns about this? Okay.
This
is
one thing, Nazar, for Arthur and his team. So this is Arthur. When do you expect this will get put into the next release of desktop? Is that going to be like in 2 weeks?
Yeah,
it's already part of the main in terms of code.
Yeah, so probably for the next in the next 2 weeks.
Okay. Okay, let's just make that's going to be really important to get rolled up before we do the next version of Gemini.
I mean, the code is already there. Like the main branch of the desktop application already uses this. It just like doesn't take advantage of like restart capability.
Oh, so it already is in the new release of Subspace
Yeah,
Desktop?
that's something that Search updated like 3 days ago. It's already there.
Okay. Okay, great. That's all I was trying to confirm.
Then there was this small pull request. Basically, when Ved was working on the Light client, he introduced some type aliases for convenience. I can just open it here. Yeah, just a bunch of type aliases. We had these in many places just explicitly. So in this pull request, I just moved them into Subspace core primitives and used that wherever I saw them. There are probably some still places missing, and these are just type aliases, so they're not new types. It is possible to mix and match different kinds. Eventually, we will probably upgrade them to new types so we can have static guarantees that this is U64 of a particular kind and not just any U64. But this was necessary for my work on the fast sync. I was using some of the libraries that Ved introduced, and I just wanted to make them consistent. So that's why I did this pull request. It's really nothing too interesting to look at. And then there was upgrade. I don't think it's worth going to that. It's mostly mechanical. The more interesting thing is this branch. It's not a pull request yet. I'm still waiting for some work from Ved. However, it does introduce a whole bunch of checks in the fast sync implementation. The gist of it is that we were having this fast sync mechanism where we are only looking at the headers. And from headers, we are trying to figure out whether we are following consensus properly or not. And in that case, how to show it? Okay, let's go here. So for that, we had this function. This is import block, and then above that there is verification for the import block. Oh wow, that's a lot of code. Okay, so this one, and we were basically calling this from the import block import, and we are trying to verify that whether the contents of the header actually matches what we expect. However, sometimes we have these events when error changes or EON changes, so we need to update randomness, and we have a specific digest item in the header that corresponds to that event. However, before we were just trusting that digest item, and if, let's say, we are updating randomness, then we assume that in the next block we need to use that randomness, but we didn't actually check whether it should have been updated in that header, or someone created malicious header and just updated because that's like more profitable for their particular plot to use that randomness at a particular point in time. So the goal of this pull request is this branch is to basically fix that and verify every single header digest item that we have that we can verify. And we have added a call to this verify next digest function that Ved created. And for that to work, we need a whole bunch of inputs. So there is a function to find era start slot that basically figures out what is the correct information about the era, like when it started, what randomness does it use. And there is also function for the EON, and there is also function for the randomness for EON, and one more to derive that randomness, which is actually copy-paste. I think we need to unify that, extract it somewhere. It's mostly the same. And then in the block import itself, we have a notion of chain constants. Those are the parameters which basically never change. And in order to not do runtime API calls, we need to store it somewhere. So we store it in the auxiliary storage. And for Gemini 1B, we just hard-coded because we know what those values are. And then we discover all of those parameters. What is the genesis slot? What is when the era starts? What the EON index and parameters are. And then we send all of those parameters to verification. And then in the end, we are also checking different edge cases, so like boundaries of era EON, and we write those values into the auxiliary storage back. And then in the very end, in the last commit, in here, we also do some pruning. So we identify when we have too deep of an narrow eon that we will no longer care about, that we don't expect forks to happen there, and we just delete them from auxiliary storage. So we only maintain the current working set instead of storage growing unbounded. So once we have more of a light client implementation where we don't have bodies at all, right now with the fast sync, we do have bodies, we just don't care about them, we don't run them. We will be able to just have a small number of headers, small number of like basically constant size of this auxiliary data for the runtime verification, and that will be sufficient for the node to basically get up to speed and then maintain it going forward. The only thing I'm waiting right now is, what are we missing? Yeah, we have ability in the runtime right now to change how we update solution range. That is necessary for seeing the history quickly. And we have two parameters. We first can disable the adjustment completely, and then when we re-enable it, we can override what the next solution range will be. None of those are expressed in the header in any way. So the fast sync doesn't really, is not able basically to follow that and to take that into account. So what we'll need to do, we'll need to add some new chain parameters that we can read during Genesis. And we can know that, yes, we've initialized with the solution range adjustment disabled. And then we should also have a digest item that will tell that it is re-enabled. And from there on, we will be following this protocol. So right now, it's not really compatible with Gemini 1B in that sense, but it does handle all the other cases if we have solution range adjustment enabled from the very beginning. So that is something I'm waiting for Red to do on the light client side, and then I will pick that up and submit a pull request with all of this. And I think that's all in terms of the code changes from last week. For this week,
question on that. So that will allow us to have a fast sync that can take into account all of these adjustments to the solution range and everything. Is that what that gives us? So right now the fast sync has a notion of just static work difficulty or solution range, and
no,
the other.
It expects that to change all the time. So it expects that solution range is adjusted every n blocks. However, if we disable solution range adjustment, that is not happening. So when the boundary comes and like time comes to actually adjust it, fast sync thinks it has changed, but it actually didn't in the runtime.
Okay, but the fast sync is still full data regardless.
Yeah, it is full data regardless, unfortunately.
Okay. And for that, is that unblocked now that we have the networking PR merged?
It is helping a little bit. I was already starting to dig into how we can achieve that, but it is very non-trivial, so I don't have any immediate updates just yet.
Okay.
Okay, and for this week, I hope to work more closely with Vedant, with Shamil and Ivan on the DSN sync, trying to get it much faster and deploy some Bootstrap nodes, at least one, so we can connect as a team to that and form a network and then see how it works on a bigger scale. Okay, I think that's it on my side. Anything else we should discuss? All right. Thanks everyone for watching then, and we will see you next week with more updates.